All right, for example 5, this is one of the vertices of the dilation of QRST, scale factor of 1/2, center dilation R. So we're dilating this figure, that's our scale factor, that's our center. The center happens to be a point R, and sometimes there won't be a point, so they might even say, let's see, 1, 2, 1, 2, 3, 4, 5, 6, 7. Maybe they'll give you an ordered pair to represent the center. In this case, R happens to be that point. They might have a point plotted that isn't one of the coordinates. I mean, again, R is this point, right? So maybe they got a point R sitting right here, maybe, that's the center dilation. So they'll give it to you that way, or they'll give you some ordered pair to represent that if you're dealing with the coordinate plane. If they don't give you a center, if it's coordinate axis, they don't give you a center, so it's just D, QRST 1/2, they want the origin to be the center. So 0, 0 would be the center in that scenario. So those are the ways they might portray this problem. But in this case, R is our center of dilation, and R happens to be a point on the picture. And rather than using our ruler when we have a graph paper to work with, we'd rather just figure out how far away they are in units and then apply the scale factor. So if I start with the letter S, how far is S away from R?
6.
1, 2, 3, 4, 6. And just 6 to the right. It's not up or down at all, right? So if I'm looking at S, it's 6 to the right and 0, and let's say 0 up. All right? So that's how I get from R to S. So R to S. So if I apply a scale factor of 1/2 to these things, so again, this is my scale factor, I'm going to get 3 right and 0 up. So the dilated image of S would be right here, 3 spaces to the right, 0 up, and that'll be S prime. So again, just identify how to get from the letter to the letter and then apply the scale factor. If we look at the letter T, R to T, and I count how to get there, I'm going to go 6 spaces to the right, and I'm going to go 1, 2, 3, 4, 5, 6, 7, 8 spaces down. And just, you're here, how do I get there? 6 right, 8 down. I apply the scale factor of 1/2 to that, and I get end directions. 1/2 of 6 is 3 to the right, and 1/2 of 8 is 4 to down. So if I start at R and go 3 right and 1, 2, 3, 4 down, this is going to be point T prime. Next point is R to Q. It doesn't matter which one you do first, by the way. I'm just going around the figure. So from R to Q, I'm counting how far to get from R to Q. I'm going 0 to the right, and I'm going 8 down. And just figure out the original directions from one point to the other. And then I'm going to apply the scale factor, 1/2. 1/2 of 0 is 0 right, and 1/2 of 8 is 4 down. So if I'm on R, I go 0 to the right, 1, 2, 3, 4 down, I end up right here. This is Q prime. And my final point is from R to R. How do we get from R to R? 0 both, right? So 0 right and 0 down, or up, take your pick. Multiply that times 1/2, and you're going to get 0 down, 0 right, correct? So 0 right, 0 down. So R prime is in the exact same spot R is. So R prime prime, S prime, T prime, Q prime have all been identified. And we just take a straight edge and we make nice straight line segments to connect them. So R prime to S prime, down to T prime, over to Q prime, and back up to R prime. And that'd be our dilated image. Going on graph paper again, just counting spaces and then applying the scale factor, multiplying by whatever that fraction is. If you did get a decimal, let's say it was 5 right, 2.5 to go 1, 2, and then kind of ballpark where a half is. So, you know, I'm not going to be getting a ruler out, making sure you got exactly a half. Try your best. Like, if you're like 2.5 is right 1, 2, and let's say it's like, that's 2.5, that's not a good try, right? So, if you wanted 2.5 from this, that kind of in the middle there somewhere. So, just make a good effort to approximate the decimal positions if you have to, but more often than not, you're going to get whole numbers to work with.